Hey there, hope you're having a wonderful day. In this video, we're going to be coding the Google Chrome dinosaur game in Java. So you probably played this game before. Basically, if you disconnect your internet and you go on Google Chrome, you'll be able to play this dinosaur game. So what you see here right in front of you is the result of this tutorial. So right now we have game over, but if I press space, we're going to reset the game. So you can see we have this little dinosaur here and we just jump and we can dodge the cactus. And the nice thing about Java is the built-in graphics library allows us to render animated images. And if I collide with any of the cactus, you can see we get game over and we get our score, okay? And if I press space, then we can play the game again. All right, so this is what you'll get by the end of this tutorial. So before we start coding, I just want to quickly mention that I am working on various tutorial projects. So if you go on my website, kennyupcoding.com, you will find a list of projects that I'm working on. And I have programming basics in Python and C++, and I have game tutorials in Python. So I have Snake and Tic-Tac-Toe, and I'll add more later on. And for Java, I have Chrome Dinosaur Game, which is this tutorial. And my next tutorial is Space Invaders. And currently I have Flappy Bird, Whack-A-Mole, Blackjack, Minesweeper, Snake and Tic-Tac-Toe. And for JavaScript, I have a ton of projects available. So I have Doodle Jump, Breakout, Flappy Bird, Space Invaders, Wordle, Candy Crush, Snake, and so on. So I will continue to work on these programming tutorials. And if this is something that you're interested in, make sure you subscribe to the channel so that you can stay up to date for future projects. Alright, so for this tutorial, I will be using Visual Studio Code, and I definitely recommend that you set up Visual Studio Code with Java so that you can follow along. And if you don't have that set up, if you go to this video description, you will find a link to one of my videos where I explain how to set up Visual Studio Code with Java. Alright, so let's start by creating a new project. So I'm going to press Ctrl-Shift-P at the same time. And we're going to do Java, create Java project, no build tools. And for the project location, I'm just going to create this on my desktop. And for the project name, I'm going to call it Chrome Dinosaur. All right, so now we have our project folder. In the source folder within your project folder, we have this app.java file, and this is going to be our main file. And we can go ahead and get rid of this line. So the first thing we need to do is create a window so that we can display our game. So I'm going to import javax.swing.*. And for our window, we need to specify a width and height. So I'm going to define two variables here. So one is going to be board width, and this is going to be 750 pixels. And then board height, I'm going to make this 250 pixels. Next, we need to create our window. So the window is a JFrame, and I'm going to call this frame, new JFrame. And within the constructor, we can pass in a title for our window. So I'm going to call this Chrome Dinosaur. All right, so now we have our window. What we need to do is set the dimensions. So I'm going to do frame.set size, board width, and board height. Then I'm going to do frame.set location relative to null. And basically, this is going to place our window at the center of our computer screen. Next, I want to do frame.set resizable. And I'm going to set this to false. So basically, we don't want the user to resize the window by dragging the window. And then I'm going to do frame.set default closing operation. And in here, I'm going to type jframe.exitOnClose. So with our window, we have an X button. And when the user clicks on the X button, we want to end our game. So it's going to end the program. So we have all our properties set up. And what we need to do is frame.setVisible true. So this is going to make our window visible. All right, now if I save and run the program, you can see we have a game window. And it is 750 pixels wide and 250 pixels tall. All right, so we have our window now, And the next thing we need is a JPanel. And the JPanel allows us to draw and render graphics. Now, here I could just create a JPanel, but instead what I'm going to do is I'm going to create a new class and have it inherit JPanel. So in the source folder, I'm going to right click, new Java file, class, and for the class name, I'm going to call it Chrome Dinosaur. Okay, so now we have a class called Chrome Dinosaur, and we want this to inherit the JPanel. So before that, I'm going to import a few things. So import java.awt.asterisk, and then import java.awt.event.asterisk, import java.util.arraylist. So these are going to be for our JPanel, and this array list is going to be for storing all the cactus in our game. And then here I'm going to do import javax.swing.asterisk. Okay, so we have our Chrome Dinosaur class, and I'm going to have it extends JPanel. So this is inheritance. And for those of you who don't know what inheritance is, basically by using this extends keyword, we are basically saying that this new class called Chrome Dinosaur, this is going to take on all the properties of this JPanel class. So essentially it is just a JPanel, but we can add some extra functions and variables within our new class. Alright, so back in our app.java, I'm going to create an instance of Chrome Dinosaur. So Chrome Dinosaur is equal to new Chrome Dinosaur. And now I created this JPanel, I'm going to add this to our window. So frame.add Chrome Dinosaur. And then I'm going to do frame.pack. And instead of setting visible here, what you want to do is set visible after you've added all the components into your window. So I'm going to do frame.setVisible true over here. So if I save and run the program, you can see there's nothing here, and our window actually got smaller, and that is because we did frame.pack. And the reason why it got smaller is when we're packing our JPanel into our window, because our JPanel does not have any specific size, the window becomes smaller. So what we need to do is add some properties to our JPanel. So I'm going to go back to this Chrome Dinosaur file, and I'm going to specify a width and height. So int board width is going to be 750, and int board height is going to be 250. Next, I want to create a constructor. So public Chrome Dinosaur. And here I'm going to do set preferred size, new dimension, board width, and board height. And I'm going to also set the background color. So before it was white, I'm going to set it to color.light gray. Alright, now if I save and run the program, you can see we have our game panel over here, and it is 750 pixels wide and 250 pixels tall, and the background color is a light gray. Alright, so now we have our JPanel. The next thing we need to do is render the images. So I want to draw a dinosaur on our screen. So before I can draw the dinosaur, I actually need to load the images. So here I only have these two files. Now if you click on the video description, you will find a GitHub link. And within the GitHub link, you'll find this image folder containing all of these images. And we have different forms for the dinosaur. So we have the dinosaur jumping, running, and we have the dinosaur when it collides into a cactus. And I've also added other images such as the birds over here. But for this tutorial, I'm only going to go over these three cactus, these three smaller cactus. There are three bigger ones, but we are just going to go over these three small ones over here. So if you click on the GitHub link, you'll find this image folder, and you'll also have the completed code, but just continue on with the tutorial and drag this image folder into your source folder. Okay, so within the source folder, I now have all of these images, and we have Dino Dead, Dino Jump, Dino Run, and this is a animated image So we are going to be rendering this image in our game. So just take the image folder and drag it into your source folder for your game project. So for this tutorial, I will be using 6 of the images. So image, dinosaur image, and this is going to be the running animated dinosaur. Image, dinosaur dead image. Image, dinosaur jump image. And then we have our 3 cactus. So image, cactus 1 image, image, cactus 2 image, image, cactus 3 image. Alright, so now we need to load these images. So within our constructor, I'm going to do dinosaur image is equal to new image icon, get class dot get resource, and I'm going to do dot slash image slash dino dash run dot gif. And then I'm going to do dot get image. Okay, so this might be a little confusing. So basically what we're doing is we're creating an image icon object over here, and we are passing in the location of the image. So get class refers to this Chrome dinosaur file here, which is over here, and get resource. So from this point on, we need to figure out where that image folder is, which is in the same folder as this file. So we'll do dot slash image slash file name. And because this class is an image icon, we actually want the image itself. Therefore, we are going to call the getImage method. So this is going to fetch the image from our images folder. And we need to do this 5 more times. So I'm going to do dinosaur dead image is equal to new image icon, get class dot get resource dot slash image slash dino dead dot png dot get image. Alright, so you want to make sure that the file extension is correct. So the first one is a animated GIF and the other one is a PNG file, okay? And just to speed things up, I'm going to copy and paste this. So here, this is going to be dinosaur jump image. And instead of dino dead, we have dino jump. And then I'm going to copy and paste again. And here we'll have cactus 1 image. And this is going to be cactus1.png. Let's copy and paste this. And over here, I'm going to change this to 2. And this is cactus2.png. And this is cactus3. And this is cactus3.png. Okay? So we have all our images loaded. Now that we have all our images loaded, we need to specify 5 things. One is the image. Then you need to specify the X and Y position, where you want to start drawing on the screen. And then you need to specify the width and height. So everything that we're drawing is going to have an X and Y position, as well as a width and height. So to make things easier, I'm going to create a simple class for all the values. And so the dinosaur and the cactus will be using the same class. And I'm going to call this block. And we'll have int X, int Y, int width, int height, and image. And then for the constructor, we need to pass in these 5 parameters. So over here, we're going to do int X, int Y, int width, int height, and image. And then this dot X is equal to X, this dot Y is equal to Y, this dot width is equal to width, this dot height is equal to height, and this dot image is equal to image. Alright, so we have this class, and I'm going to add some variables for the dinosaur. So for the dinosaur, we need to specify a width and height, as well as an X and Y position. So I'm going to create a dinosaur width, and this is going to be 88 pixels. And dinosaur height is going to be 94 pixels. And for the X position, I'll make it 50. And for the Y position, I'm going to do board height minus dinosaur height. All right, so let's go over what we did. Basically, we created a window and the height of the window is 250 pixels and the width is 750 pixels. So whenever we're drawing, we always start from the top left corner over here. So in terms of X and Y position, this top left corner is 0, 0. So we want to place this dinosaur over here. So how can we draw the dinosaur over here? Well, we said the X position is going to be 50. So this is X equals 50. And what about the Y position? So the Y position is board height minus dino height. So board height is going to end up over here. But if we start drawing from here, we're going to draw the image down here. So we want this dinosaur to be touching the floor, which is the bottom of the screen. So we're going to take board height and go back up dinosaur height. So if this is 0, 0, and the bottom right corner is 750, 250, this means that if I'm going up, we're in a negative position. And if I'm going down, we have positive. And if I'm going to the left, this is towards 0, so this is negative. And if I'm going to the right, this is towards 750, so this is positive. For that reason, when we get to the coordinate of board height, which is 250 pixels, we want to subtract and go up. So we are subtracting the amount of the dinosaur height. So basically, the X and Y coordinate is going to be X is 50, so 50 to the right. And going down, we want to do board height minus dino height, which gets us to this top left corner of this image. From there, we need to specify the width and height of the dinosaur. So the width is going to be 88 pixels. So here we have 88 pixels. And the height is going to be 94 pixels. All right, so now we have the dinosaur variables for X, Y, width, and height. Now I'm going to create a block and call it dinosaur. And within our constructor, I'm going to create a block object. So dinosaur is equal to new block. And we're going to pass in dinosaur X, dinosaur Y, dinosaur width, and dinosaur height. And then we need to pass in the image. So we're going to be using dinosaur image. And I'm going to collapse this so we have more room to see. All right, so the reason why we created a block class is we can keep track of all the X and Y positions of all the objects on our screen. So if we need to update the X and Y positions, we can do it through this variable dinosaur. Now within our JPanel class that we inherit, there is a paint component function. And it takes in a graphics object, G, and here I'm going to invoke the function from the parent class, so super.paintComponent G, and then I'm going to create a new function called draw. So I'm going to call draw and pass in the graphics G. So let's define draw, so public void draw graphics G. And here within this function, we're going to do all the drawing. So you can draw rectangles. So for instance, if I want to draw a rectangle, I would do g.drawRect, and this will draw a rectangle where we pass in X, Y, width, and height. But we want to draw images. So here I'm going to do draw image, and I'm going to pass in the image first. So this is going to be dinosaur.image, dinosaur.x, dinosaur.y, dinosaur.width, and dinosaur.height. And it seems we're getting an error here, and that is because there is another parameter that we need to pass in. And for that, we don't need to pass in anything. It's just an extra parameter that we need to specify. So here I'm just going to pass in no. Okay, so we have our draw function over here. And now if I save and run the program, let's see what happens. And you can see we do not see the dinosaur. And that is because we are trying to render an animated GIF. When we are creating JPanel, paint component only gets called once, and it's going to call draw, and it's only going to draw the first frame. So instead of using the GIF image for now, I will just use the PNG static image to show you that this renders. So for the dinosaur image, because it's a GIF, we want to change this to dino-run1.png. So this is just the first frame of the GIF. So if you look in the source images, it's this image here, and the second frame is this one, okay? and together they create this animated GIF. So just to show you that this works, I'm going to change it to this image for now. And let's save and run the program. And you can see we have our dinosaur image over here. Alright, so I'm going to change this back. So this is dino-run.gif. And we're going to continue with the tutorial. So now that we are able to draw the image onto our game panel, what we need to do is create a game loop. So we're going to use a timer for the game loop. And if you ever played games before, you know that there's something called the refresh rate. And basically, it's how many times the game renders new images per second. So basically, I'm going to use a game loop. And this is a timer, and we are going to do 60 frames per second. So this means that every second, we are going to draw 60 times. So here, I'm going to create a timer, game loop. So down here in our constructor, I'm going to do game loop is equal to new timer. And we need to specify two parameters, the delay and action. So the delay is going to be 1000 milliseconds, which is equal to 1 second, divided by 60. So this is going to be about 16.67, and this is in milliseconds. So every 16.67 milliseconds, we're going to call an action. And this needs to be an action listener. So if you hover over the timer class, you can see we need to provide an action listener. And for the action listener, I'm going to do this. So this refers to the Chrome Dinosaur class. And currently this Chrome Dinosaur class is just a JPanel. So up here, I'm going to add an interface. So we're going to do implement action listener. So now this means that this Chrome Dinosaur will have this action listener property. So here, if I hover over this, you'll see that we need to define an action performed. So I'm going to click on quick fix, add unimplemented methods. And if I save and I scroll down, you can see we have this action performed function. So basically, this action performed function is going to be called 60 times per second using the game loop timer. So here, I'm going to get rid of this. And what do we need to do? So 60 times a second, we refresh the screen. So we need to draw again. So there is a built-in function within JPanel called repaint. And repaint is going to call paint component, which we'll call draw. Okay, so it's going to call repaint, which will call this, and then this will call the draw function that we defined here, and it's going to do so 60 times per second. Okay, so we have our game loop here, and we need to start the timer. So I'm going to do game loop dot start. All right, now if I save and run the program, you can see we can now render our animated GIF. So basically, our screen is updating 60 times per second. Now that we have our game loop and our dinosaur, we want to make the dinosaur move. So if I press the spacebar key, I want the dinosaur to jump. So let's go ahead and implement that. So for the game physics, we'll have int velocity y. So y is the vertical position, so it's up and down. And I'm going to set this to 0. So if you remember, this top left corner is 0, 0. And this bottom right corner is 750, 250. So if I want to move up, we need to subtract because it's going towards 0. So if I want to jump, the velocity y needs to be negative. And if I want to go down, the velocity y needs to be positive. So velocity is simply a change in position over time. So for instance, let's say I had velocity y, and I set this to -2. So our game refreshes 60 times per second. So in the first frame, we have -2, and then in the second frame, we have -2, and then in the third frame, we have -2, right? Basically, if velocity y is -2, we're just going to go up at a rate of -2 per frame. So after 3 frames, we'll have -6. And these aren't the actual numbers we'll be using. This is just for an example on how I'm explaining the physics of the game. So when I press a button, I want the character to jump up. So in order to process key inputs, I'm going to implement another interface, and that is key listener. And like with action listener, we need to define some methods. So if I hover over Chrome Dinosaur and click on quick fix, add unimplemented methods, we're going to get 3 methods. So let's scroll down, and we have key typed, key pressed, and key released. So key typed is for when you're typing on the keyboard, we are getting the character. We are getting the value of the key. So let's say I press on A, we're going to get the character A. And if I press on F5, then that gives us F5, but there's no character called F5. So we're not going to be using key typed. So let's collapse this. And key press is basically whenever you press on a key. And key released is when you press on a key and you let go, the key goes back up. That's when it triggers this event. So I want to allow the user to just do key press so that they can hold on to the spacebar key and the dinosaur will jump, go back down, and jump again. So I'm going to do key press. This means that we will not be using key released. And for key pressed, I'm just going to get rid of the code here. And I'm going to copy and paste this and move it up here, okay? So the key press takes in a key event, and I want to process the key event. So here I'm going to do if e.getKeyCode is equal to key event dot vk underscore space. I'm just going to print. So system.out.println jump. Now, if I save and run the program, let's see what happens. So we have our dinosaur running, and if I press space, you can see we get nothing printed out. So this means that this key press is not being registered. So we need to do a few things here. So I'm going to go back up, and in our constructor, I need to add 2 lines here. Set focusable true. So this is going to make sure that this JPanel is going to be the one listening for key events. And we also need to add the key listener. So I'm going to do add key listener. And because we are using the interface key listener, just like with the action listener, I can just do this. So this refers to the Chrome Dinosaur class. And one more thing, we want to go back to this app.java file. And over here, right before we set visible, I'm going to do Chrome Dinosaur dot request focus. All right, now if I save and run the program and I press the space bar, you can see jump, jump, we're jumping, okay? So now we know our game can listen to our key inputs. So let's actually make this dinosaur jump. So I'm going to comment this out and I'm going to do velocity y, and I'm going to set this to -17. So this is the number that I figured out. Basically, whenever you're jumping over the cactus, you want to be able to just jump over it. You don't want the dinosaur to jump too high or too low. So I figured out that for these numbers, -17 works perfectly. All right, so we changed the velocity. Now what we need to do is update the y position of the dinosaur. So over here, I'm going to create a new function that will handle all the movement updates for the objects on the screen. So here I'm going to do public void, and we're going to call this function move. So here I'm going to do dinosaur.y plus equal velocity y. And then in our action performed, right before we repaint, we want to update the y position. So here I'm going to call move. So basically, this is 60 times per second. So every frame, we are going to update the position and repaint. So it's basically a loop. You update position, then repaint, update, repaint, update, repaint, okay? So if I save and run the program, you can see we have the dinosaur. And if I press the space bar, we go up, okay? So the dinosaur flew up forever, and that is because we do not have any form of gravity. So without gravity, the dinosaur is just going to go up forever. So over here, I'm going to add gravity. So gravity is going to be 1, and 1 is a positive number. So if it's positive, it's going downwards. So for those of you who aren't familiar with physics, let's say I set velocity y to -6, and we have it as -17 in our game, but just for this example, I'm going to make it -6 to make it simpler to explain. And let's make gravity +2. Okay, so on the first frame, the dinosaur will move up by -6 pixels. Then we update the velocity y and add 2 to it. This becomes -4. So in the next frame, it only goes up -4. And then we add 2 to it again, and we get -2. And then we add 2 to it again, and we get a velocity y of 0. So 0 means the dinosaur no longer moves. So this is the stopping point. And then in the next frame, we add 2 again. Now velocity is +2. So positive is going downwards. And then we have +4 and +6 and +8 and so on. And basically, the dinosaur is just going to keep falling forever unless we add a check to make it stop on the ground. So the idea with the physics is basically the time it takes for you to go up is the same time it takes for you to go back down. So we have gravity as 1. So if I scroll back down, in our move function, before we update the y position of the dinosaur, I want to update the velocity with the gravity. So velocity y plus equal gravity. So if I save and run the program now, you can see the dinosaur falls off, but I can just press the space bar and it'll hop back up, okay? So it is hopping and falling at the same time. So as long as I press the space bar, it'll go up. So there are two issues here. One, the dinosaur should not fall past the ground. And two, I should not press the space bar to have it jump unless it is touching the ground. So over here, I want to make the first check, and that is if dinosaur.y is greater than dinosaur y. So dinosaur y is basically the starting position that we placed up here when we were creating our object. So this is the starting position, and the starting position is basically the dinosaur touching the ground. So if it's gone past this starting position, that means the dinosaur has gone past the ground. What I'm going to do is set dinosaur.y equal to dinosaur y. And I'm going to set velocity y equal to 0. So if I save and run the program, you can see the dinosaur is on the ground, and if I press up to jump, it'll fall back down and land on the ground again. And as I mentioned earlier, if I press the spacebar twice, you can see the dinosaur can fly upwards. So in key pressed, I'm going to add another check. If dinosaur.y is equal to dinosaur y, then we change the velocity. So now the dinosaur should only be able to jump if it's touching the ground. So let's save and run the program. And you can see we can't double jump. We can only jump if the dinosaur is touching the ground. And now what I want to do is I want to change the sprite to a jumping sprite whenever the dinosaur jumps. So it doesn't look like the dinosaur is running in the air. So to do that, I'm just going to do dinosaur.image is equal to dinosaur jump image. And when we land on the ground, we also want to change this back. So dinosaur.image is equal to dinosaur image. So when we jump, we change it to the jump image. And when we land back on the ground, we change it to the running image. All right, so now if I save and run the program, and you can see the dinosaur is running, and if I jump, okay, so the dinosaur is not changing image. So there's a bug somewhere. Okay, so it's probably in the draw function. Okay. So here I'm using dinosaur image. What I should be doing is dinosaur dot image. So that should fix it. Now if I save and run the program, all right, the dinosaur is running and I jump, now it's jumping. And then when it falls back, it's running and I jump, drops to the ground, it's running again and I jump. And we have a nice dinosaur that's able to jump. Okay, cool. So now the next thing we need to do is add the cactus so that the dinosaur can hop over the cactus. So let's go ahead and do that. So just like with the dinosaur here, we need to specify the width and the height and the X and Y position for the cactus. So we have 3 different cactuses or cacti, and each one has a different width. So we have 1 cactus, 2 cacti, and 3 cacti, and they all have the same height. So let's specify these values here. So int cactus 1 width is going to be 34 pixels wide. Int cactus 2 width is going to be 69 pixels wide. Int cactus 3 width is going to be 102 pixels wide. And the height is going to be int cactus height 70 pixels. And the X position, I'm going to make it 700. So int cactus X is equal to 700. So the width of the screen is 750. So I'm placing it at 700 so that the user can kind of see the cactus. And the Y position is going to be just like with the dinosaur Y position. It's going to be cactus Y equal to board height minus cactus height. So this is going to place the cactus onto the ground. And because we have multiple cacti, we want to store them in an array so that we can access them more easily. So here I'm going to do an array list of block, and we're going to call this cactus array. So the dinosaur is just constantly running, and the cactus is going to be randomly generated. So we are going to use a timer for the cactus. So timer, and we're going to call this place cactus timer. So over here, I'm going to create an array list. So cactus array is equal to new array list block. And just like with the game timer, I'm going to create a timer for the cactus. So here I'm going to do place cactus timer is equal to new timer. And I'm going to generate a new cactus every 1500 milliseconds. So this is 1.5 seconds. And we need to provide an action listener. So in the game loop, the Chrome Dinosaur class was the action listener that would update the screen. Here we are going to create a new action listener. So I'm going to do new action listener. And we need to specify an action performed. So I'm going to do override public void action performed action event E. And don't forget the semicolon down here. So the action performed is going to call a function called place cactus. So let's define that down here. So I'm going to do void place cactus. And here I'm just going to write a little strategy on how we determine which cactus appears. So obviously, if you have 3 cactus together, that's going to be more difficult to jump over. So we're going to make the chances different for each cactus. So I'm going to use a random function. So double place cactus chance is equal to math.random. And this gives us a number between 0 and 0.99999. And based on this number we get from the random function, we're going to determine which cactus to place. So if place cactus chance is greater than 0.90, then I'm going to create a block. Cactus is equal to new block. And this is going to be cactus X, cactus Y, cactus width. And which one we're going to choose? We'll do cactus 3 width and cactus height and cactus 3 image. So basically, only 10% of the numbers are going to be above 0.90 because this is the range. So this basically means that we have a 10% chance to get cactus 3. And then afterwards, I'm going to add this cactus to the cactus array. Okay. So let's do the same for the other 2. So else if place cactus chance is greater than 0.70, then we get cactus 2. So block cactus is equal to new block cactus X, cactus Y, cactus 2 width, and cactus height, and cactus 2 image. And then cactus array dot add cactus. So this is going to be any number between 0.70 and 0.90. So this is actually a 20% chance you get cactus 2. Because all the numbers between 0.70 but not greater than 0.90. So you have 20% of the numbers here. And then we're going to do the same for the cactus 1. So else if place cactus chance is greater than 0.50, then block cactus is equal to new block cactus X, cactus Y, cactus 1 width, cactus height, and cactus 1 image. And then cactus array dot add cactus. So this is all the numbers between 0.50 and 0.70. So this is 20% as well. So if we add all these numbers up, basically, if we get a number from 0.50 all the way to 1.0, or basically this number over here, 0.99999, then we have a 50% chance of actually getting a cactus every 1.5 seconds. Okay, so this is going to generate a cactus and add it to the array. So 50% chance we get one of these, and 10% chance for the 3, 20% chance for 2, and 20% chance for 1. Okay, so now we need to draw the cactus. So in the draw function, I will go through the array list and draw image for each cactus. So over here, I'm going to do for int I is equal to 0, I less than cactus array.size, I++, block cactus is equal to cactus array.get I, and then we're going to do g.drawImage, cactus.image, cactus.x, cactus.y, cactus.width, and cactus.height, and null. Okay, so we iterate through the cactus array and we draw each individual cactus. And we need to do the same for moving. So when we move the cactus, we are going horizontally. So if I scroll back up, over here, we have velocity y for the dinosaur jump. And basically, the way this game works is the dinosaur physically never changes x position. It only goes up and down. Instead, we change the position of each cactus. So we make them negative x. So basically, they're going to the left side. And if the cactus is going to the left side, this simulates the dinosaur running to the right side. So here I'm going to do int velocity x, and I'm going to make it negative 12. So let's go back to our move function. So again, we're going to move each cactus within the array list. So for int I is equal to 0, I is less than cactus array dot size I++. We're going to get the current cactus at this index. So block cactus is equal to cactus array dot get I, and then cactus dot x plus equal velocity x. So we move the cactus and we draw the cactus. So this should be fine. And if I save and run the program, let's see what happens. So 50% chance that a cactus will appear and nothing appears. Okay, so let's exit this. And the reason why nothing appeared is because we are not calling place cactus. So here we needed to start the timer. So over here, I would do place cactus timer dot start. Okay, so now let's save and run the program. All right, so the cactus should be appearing. Okay, and they're passing us, so I can jump. Okay, so we have the cactus generating every 1.5 seconds with a 50% chance. Now what we need to do is detect collision between the two. So detect collision between the dinosaur and the cactus. So let's use a collision detection formula. So this is going to return a Boolean. So let's call this function collision, and it's going to take block A and block B. And I'm not going to explain this formula because it might be a little difficult to explain for this video. So I'm just going to write out the formula. And essentially, it's a formula that detects the intersection between two rectangles. So I'm going to do return a.x less than b.x plus b.width, and a.x plus a.width is greater than b.x, and a.y is less than b.y plus b.height, and a.y plus a.height is greater than b.y. So this is a formula for detecting the intersection between two rectangles. And if two rectangles intersect, that means we have a collision. All right, so now we need to call this function to check. So within our move function, over here, I'm going to do if collision between dinosaur and the current cactus, we want to set game over to true. So for now, I'm just going to set the image, dinosaur.image to dinosaur dead image. And then later on, we're going to apply the logic for game over. So let's save and run the program. And you can see I'm jumping, and let's see, I collide and we change image. Okay. So there's a collision over there. And let's try to hop over one of the cactus. So, okay. So for a brief moment, you can see it changes image. So our collision detection is working. So what we need to do is stop the game when we have game over. So over here, let's add a Boolean game over and set it to false. So there are a few things that we need to do here. And first, I'm going to go to our collision function, or rather where we detect collision. And if we have a collision, I'm going to set game over to true. So what happens when game over is true? We stop the game. So in our place cactus, I'm going to make a check if game over, return. So if we get game over, we're going to stop at this point. So we're not going to do the logic for generating the cactus. And then I'm going to scroll down to where we have our action performed. And here I'm going to do if game over, we're going to stop the timers. So place cactus timer dot stop. So it's actually no longer placing the cactus, and game loop.stop. So this is going to stop the game loop from updating the frames of our game. Okay, so now let's save and run the program. Okay, so I'm playing the game and we're running, and let's jump over this one and let's collide with the next one. Okay, boom. So we collide with the cactus and we get game over. And you might notice here that it actually doesn't look like we're colliding with the cactus. So basically, how the game works is we have these images that are actually rectangles. So this whole thing is part of the dinosaur. This empty space is also included. So what we see is just the dinosaur itself, but what the program sees is this whole rectangle is part of the dinosaur. And the same applies for the cactus. So the cactus is also a rectangle. So what you see may not look like a collision, but logically, we have an intersection between these two rectangles. Therefore, the dinosaur is actually colliding with this cactus. Okay, so we have collision and the game no longer works. I can't jump anymore because the game stopped. And so what we need to do is add scoring and reset the game. So let's add scoring first. So we're going to do int score and set this to 0. And we update the score every time we update the frames. So I'm going to go into our move function because we're calling move in our action performed. So I'm just going to do it here and do score plus plus. Okay, so this is going to add 1 point to our score every frame. So now that we have our score incrementing, we want to draw the score. So in our draw function, I'm going to do something for the score. So here I'm going to do g.setColor, color.black. So this is going to set the font color of our pen, and we need a font. So g.setFont, new font, and I'm going to use Courier, font.plain, and the font size will be 32. Okay, so here I'm going to make a check. If game over, I'm going to do g.drawString game over plus string.value of score, and I'm going to place an X and Y position. So this is going to be 10 and 35. So 10 to the right and 35 down. Else, I'm going to do g.drawString, and we're not going to put game over. We're just going to do string.value of score, and same thing, 10, 35. All right, now let's save and run the program. Okay, so you can see the score is incrementing, and I can jump over these cactus, and let's keep on running. Okay, and then we collide and we get game over, and it now shows our final score. Okay, so we have a functional game of the Chrome Dinosaur game, and now we just need to add one more thing, and that is when the dinosaur collides, we get game over. We want to be able to reset the game by pressing the spacebar. And resetting the game is actually very simple. So we're going to use this key press function, and we're going to use the same key, which is the spacebar key. So here we're going to make an extra check. So if game over, so what do we need to reset? Well, we need to reset the dinosaur.y and set it to dinosaur y. So the dinosaur can go up and down. So basically, if it's jumping and it hits a cactus, then it's going to stay in that Y position. So we want to reset it so that it's back on the ground. And then we want to reset the image. So dinosaur.image. Currently, it'll be the dino dead image. We're going to make it dinosaur image. So this is the starting image, which is the running animation. And then we want to reset velocity Y to 0. So the dinosaur is not in the air. And I think that's all we need for the dinosaur. As for the cactus, we can just destroy all the cactus in the array list. So I'm going to do cactus array.clear. And then we need to reset a few things. So I'm going to set score back to 0, set game over back to false, and then we want to start the timers again. So I'm going to do game loop and start it again. And then we want to start placing cactus. So place cactus timer dot start. Okay, so let's save and run the program. Okay, so we're running, and let's jump over this and this one as well. Let's play the game. Okay, I'm just holding the space bar. eventually will collide, and there we go. So game over, and I press the spacebar again, we restart the game. Okay. Alright, so we have a fully functional game of the Chrome Dinosaur in Java. And one more thing I want to add is within our place cactus function, we are adding a new cactus to the array list every time. And eventually, each cactus is just going to go off the screen. But we need to clear this because we don't want the array to have all the dead cactus or dead cacti that is already off the screen. So let's say you're playing the game and you run past 10,000 cactus. Those 10,000 cacti are going to be in the array list, and we are iterating through the array list to make the check for collision and drawing. So we need to do some cleanup here so that the array list doesn't continue to grow and slow our program down. Now here you can use a while loop, but I'm just going to do a simple check and say that the maximum size the cactus array should have is 10. So if cactus array.size is greater than 10, and we can assume that after 10, the first few cacti are just going to be off the screen, but here I'm just going to make it 10. I'm going to do cactus array.remove index 0. Okay, so this is going to remove the first cactus every time we hit 10 cacti in the array list. So this is going to ensure that we are only going to have at most 10 cacti in the array list. So let's save and run the program. Okay, so we're running and I jump over this. Come on. Okay, there we go. And I collide. And if I press the spacebar, we play the game again. Alright, so we have a fully functional game of the Google Chrome Dinosaur game written in Java. And you can continue working on this game if you want. You can replace the images with sprites that you create yourself. Or if you want a challenge, I encourage you to improve this game by adding these birds. So if I double click on this, this is an animated bird image. So you can add that on top of these tiny cacti, and you can also include these big cacti. You can also implement a feature for the dinosaur to duck, and you can also add a feature that keeps track of the high score. So these are some ideas that you can use to improve the game if you want to continue working on the game. But yeah, that's it for this tutorial. And if you found this tutorial helpful, make sure you leave a like. If you have any questions, let me know down below in the comments. And if you want to stay up to date for more project tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.